Hello.
Hi, how are you doing?
Good. I
Good?
had a question.
Yeah.
Um, about your one-on-one tutoring.
Mm-hmm.
We have to go to the My Night Star to register for that, or
Yes,
how does that work?
you gotta go to My Nice Star. Wait, let me share the link so that you better you get a better understanding on how to, because they have this stepwise uh thing. Wait.
Yeah, it can be kind of hard to navigate
Yeah,
sometimes.
I understand. I understand. Just a second. Okay. So where did the chat go? Okay, so I shared you the link on how to schedule the one-on-one appointments. Follow that link, and if you have more problems, just email me or something,
Thank you.
Yeah, anytime. Okay, I guess I'll wait for like 3 more minutes. We'll start at 4:05. Let's see if more people joins. You guys can see my screen, right?
Yes.
Oh, what happened?
Yes, we can see it.
See it?
Or we could at one before.
Yeah, I don't know what happened. Wait. The connection got lost. Okay, interesting. Okay. Oh, okay. I'm sorry about that. Okay. We have 2 people coming. Okay, perfect. Okay, I had like 10 people here. It's okay. I mean, most of the time people end up watching the recording. So let's start. So these are all textbook problems. So, I mean, they look simple, but it's like you have to be very cautious about little things which can like affect your answer uh, very much. So what I'll do is I'll read the question first. I'll ask like a couple of things to you guys. I want it to be like an interactive session, but it's okay. Like if you don't know anything, I'm gonna like this is a review, so I'm obviously gonna give you everything. So yeah, we'll start with the first question. So baseball player hits 5.1. Okay. Okay, so guys, I would like if you guys just unmute yourself and just ask me questions, because I don't usually see the chat while I'm doing it. But okay, is this recording going to be posted in web courses? So it's not gonna be posted in web courses, but I will post an announcement and I'll share the link to my WordPress site, and I'm gonna post the recording on the WordPress site. And I'll also post the worksheet, whatever I do here right now. So does that answer your question? Okay, perfect. Yeah. Okay, so a baseball player hits a 5.1 OZ ball with an initial velocity of 100 feet per second at an angle of 40 degrees with the horizontal as shown. Determine the kinetic energy of the ball. Determine the kinetic energy of the ball immediately after it is hit and the kinetic energy of the ball when it reaches its maximum height, the maximum height above the ground reached by the ball. Okay, so we gotta start this question. First of all, what we need to do. What happened here? Okay. Okay. So first, what we need to do is just write whatever is given in the question. In the exam as well, just write first whatever is given in the question and then try to solve it, because it's much easier to know. You know certain things and then you find the unknowns. So the given things here. Okay. The given things is, what happens? Mass is 5.1. Velocity, initial velocity is 100 feet per second. Okay. And if I want to convert this, first of all, do all the conversions. You want this in pounds because your velocity is in feet per second. So what you want to do is just divide this by 5.1 by 16. So that will give you 0.31 pounds. Okay. So that's the only thing given to us. What we gotta find is, first is kinetic energy after the hit. So kinetic energy after hit. Second thing is the kinetic energy of ball when it reaches the maximum height. So Ke at H max. And third is the height, maximum height. Okay. So we gotta solve these three questions. So kinetic energy immediately after the hit, what would it be? It's very simple. Like this is like just a warm-up question, to be honest. This is like just applying formulas, that's it. So how do you find the kinetic energy after the hit? Does anyone have any idea?
Is it 1/2 mv squared?
Awesome. So it's just 1/2 mv squared. We have mass, we have velocity. So kinetic energy after the hit will be equal to 1/2 mv squared. That would be equal to 1/2 mass. Make sure this is 0.31 is the weight. This is weight. So weight equals mass times gravity. So mass will be equal to weight times gravity. So that would be 0.31 pounds over gravity is 32.2. V squared, there's going to be V naught squared. So it's going to be 100. Square. This is going to equal to 0.5 times 0.31 over 32.2 times 10 to the power 4. So the kinetic energy after the hit will be equal to 48.13 joules. This is part A of the question.
I have a question real quick.
Yeah.
So we divide the 0.31 by 32.2. That's because that's the weight and we're trying to just get the mass.
No, we are trying to find the mass from the weight. 0.31 IB, like 0.31 pounds, is gonna be the weight of the ball. And we want mass. So mass is gonna be weight over the gravity.
Okay, so that's why we divide it by the gravity.
Yes, that's why we
Okay.
divide. Yeah.
Thank you.
So kinetic energy will be 48.13 joules, right? This is pretty simple. The first one was pretty simple. Second one is you gotta find the kinetic energy at maximum height. Okay, so at maximum height, what will be the only thing that will change at this height?
Velocity.
Velocity. Awesome. Velocity will change. Velocity is what component of velocity we will take?
Say that
The
again.
What happened?
The X component?
The x component. Oh, awesome. The x component. So we'll take for part B for kinetic energy at h max. So velocity would be v naught cosine of what was the angle? 40. So this will be 100 cosine of 40, and that would be 76.6 feet per second. Make sure you write the units for everything so that you don't get confused. So the kinetic energy again, it's going to be equal to half mv square. So this is going to be equal to half. Mass is again 0.31 over 32.2 times 100 cosine of 40 square. So that's going to be 76.6 square. So this is just going to be 28.24 joules. Okay. So you see there is a, if you understand it concept wise, there is a drop in kinetic energy because it is at height 2 feet. So if there is a drop in kinetic energy, the total energy is going to be the same initially and finally. So if there is a drop in kinetic energy, there must be some potential energy. And at 2 feet of height, there is a potential energy which is equal to mgh. So if they don't give you the height, if I change the question and if I say that find, if don't give you these 2 feet, find the height when the kinetic energy, find the h max from this given question. So what you'll do is just equate kinetic energy equals potential energy. Kinetic energy at maximum height would be the one which we found. Just equal it to mgh. You have mass, you have gravity, you can find h. Does that make sense?
Yes.
Does it make sense? Okay, perfect. I mean, in this question, it doesn't tell us to find the h because they have already given the maximum, the height. But if in any chances, like, you know, you got to think about things. The kinetic energy 48.13 initially, after it reaches to a maximum height or a certain point, it reduces. That means it has some potential in it because total energy remains the same. So that is what chapter 13 is all about. We just play with energies. That's it. Chapter 13 and 14, I guess, as well. So you just got to understand the concept here. Okay. Now they are telling us to find the maximum height. Okay. So the maximum height is going to be, again, as I told you, it's going to be, it's going to be, what we will use is total energy initial is equal to total energy final. So total energy initial, again, kinetic energy initial plus potential energy initial is equal to kinetic energy final, or kinetic energy final means kinetic energy at maximum height. Plus potential energy final. Kinetic energy initial is 48.13 joules, which we already calculated. is going to be 48.13 joules plus potential energy initial. Potential energy initial, what is going to be? mgh. Mass is 0.31 over 32.2. Gravity is 32.2. And h is 2 feet,
Two. Yeah.
right? H is 2 feet. Will be equal to kinetic energy final. Kinetic energy final will be kinetic energy at maximum height. So it would be 28.24 joules plus mass. Mass is 0.31 over 32.2. G is 32.2. And H max, which we have to find. So if you do the calculation, like just try to solve as much as possible, you'll find that your H max is going to be 66.1 feet. This is H max. First, we found the kinetic energy. Second, we found the kinetic energy at maximum height. Third, we found the maximum height. First two, we just use kinetic energy equation and the velocities at those points. The third one, we use conservation of energy. Total energy initial equals total energy final. So kinetic energy initial, we had it. Potential energy initial at 2 feet, we already had it because ball was at 2 feet at the start of the motion. And then kinetic energy final, which we got at maximum height in the second part of this question. And then potential energy final, it will give you the maximum height, which is potential energy basically mgh. So you can get the h. So any questions in this particular problem? And you guys, you can just take a screenshot of whatever you want. I don't mind anything. I'm gonna post this, but if you want to take screenshots, I'll just tell me to minimize the screen and you can take screenshots for. I know it's much easy to just take the screenshots and then look it over again. So just let me know if you want to take that. And also just unmute yourself or just write it in the chat, and never mind, if I see the chat early I can just respond, but let me know if you have any problems in any step. It can be anything. Don't feel that it's such a small thing, because small things in dynamics really matters. So just let me know if you have any questions at a particular step.
So does the kinetic energy for the 48.13 joules, that is our initial, counts as our initial kinetic energy?
Yes, that is our initial kinetic energy, because we use the initial velocity. That is our kinetic energy at 2 feet, because initially the ball is at 2 feet. It's not at origin, or it's not on the horizontal. It's 2 feet up, and then the striker hits it. So this ball is already at 2 feet. So that the velocity there at that particular point is the initial velocity, which is 100 feet per second.
Okay, I was just a little confused at first because we're using the kinetic energy as initial, but the overall was looking for after the hit. But we're just looking at right as he's swinging the bat.
Yeah, right.
Right.
He's swinging the bat, and it's like when he swings the bat right after the hit, like right time second would be like milliseconds. Right after the hit, he wants the kinetic energy, and when it reaches the maximum height, like if this is the striker, I don't have a ball, but I mean, I don't know what I can use. But if he hits it, so the ball is gonna be in like a projectile motion or something. So at maximum height, he wants a kinetic energy. So first you'll calculate the kinetic energy initially, and then you'll calculate the kinetic energy at maximum height. Does that make sense now?
Yes, thank you.
Yeah. Okay, yeah. Visualizing dynamics problems, it will really help you solve the problems because you know actually what is happening. And I have discussed these questions in my previous sessions as well, in person, in my normal regular sessions for peer tutoring. And there was one guy who solved this problem using projectile motion. So there are different ways of solving dynamics problems. It's just how you visualize it, and it's just how you have the better understanding of chapter 11 and 12. So you can solve this question with the help of projectile motion as well, because at maximum height, your final velocity is going to go to 0. So then you can calculate the change in height or delta y or something. So yeah. Okay. So if no questions, we can move further. This question, yeah, I just solved it in my today's session in 11 to 1. I don't know, some of you are here from that session. So this is gonna be repeated. So let's do one thing. The people who are here, I know it's gonna be very boring for you guys. So I'll just skip this for now. I'll do this at last, but I'll just skip this for now, and we'll do this problem, the pool problem. Okay. Okay. In a game of pool, ball A is moving with a velocity v0. When it strikes ball B and C, which are at rest and aligned as shown. So ball B and C are initially at rest, so their initial velocities are going to be 0. Knowing that after the collision, the three balls move in the direction indicated, and that the initial velocity is 10 feet per second and VC is 3.9 feet per second, determine the magnitude of velocity of ball A and ball B. Okay. So does anyone of you know how to solve this problem? Have you seen this problem before? Have you tried to solve this problem before? It's a nice problem. Do you guys have any idea? First of all, if you know nothing about the problem, just write whatever is given. Just write it. Doesn't take much time. Given is the initial velocity, 10 feet per second, and VC is 3.9 feet per second. Okay. VC, V0, and VC. Okay. And wow, there's nothing else given. I thought in this problem everything was okay. Yeah. There are just two things given to us. Okay. So we're gonna use conservation of momentum here, right? So conservation of momentum. So we can use mass of A times V0 equals this V naught obviously will be a vector because it is striking at 45 degrees to the horizontal. And that V naught mass of A times V naught is going to equal to mass of A times VA plus mass of B times VB plus mass of C times VC. Okay. Are we given any masses, or we just been given this velocity and this velocity? So 1, 2, 3, 4, 5, 6 unknowns. 6 unknowns, 6 equations, right?
Yeah.
So you want to do 6 unknown, 6 equations? What is the trick in this? They
But
are,
all the balls weigh the same.
yeah, all the balls weigh the same. You can just take off the masses. All the balls weigh the same. So mass of A, it's a game of pool. So mass of A is equal to mass of B is equal to mass of C. So they go away. So your final equation VA plus VB plus VC. And what do we need to find? Velocity of A and B. So 2 unknowns. We need 2 more equations. Oh, sorry. This one is given. Now we got to take momentum in X direction and conservation of momentum in Y direction, because the angles are involved with the Y-axis and X-axis when the balls hit each other. So what we're going to do is first we'll take conservation in X direction. So in X direction, this velocity here will have 2 components, 1 and 2. This will be V naught sine of 45, and this will be V naught cosine of 45, right? So in X direction, I have one component, it's going to be V naught cosine of 45. This is going to equal to, because this velocity V naught then splits up into VA, VB, and VC. So this component of this velocity will then split up into X components of VA, VB, and VC again. So VA is here, it's going to make this angle. So this is going to be VA cosine of 4.3, and this, yeah, and 3. Right? Does everyone agree with this? Do you guys get it?
Yes, I think so.
Okay. So in X direction, we have VA 4.5, sine of 4.5. Oh, it's not 4.5, it's 4.3, sorry. Again, the same thing with VB. VB is here. So this component is going to be VB cosine of 37.4. And this component is going to be VB sine of 37.4. So plus okay. Same thing for VC. This is going to be VC cosine of 30 sine of 30. So plus cosine of 30. Let me know if I'm going too fast, because this question, it's much easier to like go slow because people tend to get confused between the velocities. Okay. So now we'll just substitute whatever we have in the given to us. So this would be 10 cosine of 45 equals VA is given. No, it's not given. So sine 4.3 is 0.075 VA. Sine 37.4 is 0.6014 VB. Plus VC is given. Was VC 3.9 cosine of 30. So equation here, first equation would be 0.075 VA plus 0.6074 VB will be equal to 3.694. This is our first equation. Of course, we have two equations. We need two unknowns, right? So second would be conservation of momentum in y direction. Similar, we already have the components with us. So in y direction, for V naught, it's V naught sine 45. Equals what did I do? Oh, space. Okay. Too bad with technology. Okay. Anyways, we have V naught sine 45. Then we're gonna have VA cosine 4.3, which is equal to VA cosine 4.3. Now VB is going down, so it's gonna be VB, negative VB. You see here, VB is going down, so it's gonna be negative VB cosine of 37.4. And the last component, VC, is going to be plus VC. VC is going up, VC sine 30. So VC sine 30. And again, we will substitute everything we know. So it's going to be 10 sine 45 equals VA is cosine 4.3 is 0.997 VA minus cosine 37.4 is 0.7944 VB plus cosine 30. So I have the final equation as 0.0, no, it's not 0.0, 997 VA minus 0.7944 VB equals 5.121. This is my second equation. Two equations, two unknowns. Can you guys solve for VA and VB from here? Do you want me to solve or you guys are good with it? Richard says he is good. Okay, perfect. I mean, it's easy, like solving simultaneous equation. It's just V and VB. So yeah, okay, perfect. If everyone feels good, then I'll just write the final solution for VA is gonna be 9.09 feet per second, and VB it's gonna be 4.96 feet per second. So these are gonna be LV. Try solving this by your own afterwards or whenever you have time and see if your answer matches with 9.09 and 4.96. It should match. I mean, the equations here look good. So anyways, any questions in this particular problem?
I have one question.
Yeah.
In the Y, when you move the two, the 3.9 sine 30 to the other side, I got negative 5.121 instead of positive.
You got negative?
Yeah. Maybe I moved it to the wrong side. That might have been it.
So what value of VC sine 30 do you get? 3.9 sine 30. So sine 30 is half. So 3.9.
1.95.
Yes, 1.95. So
Yeah.
10 sine of 45 is gonna be 7.071.
Okay, I just did it the other way around.
Oh,
That's why
that's
it's
okay.
negative.
Yeah, that's okay. 7.071. And this is gonna be what was it? 1.95. So then you get 5.121.
Okay, thank you.
Yeah.
Can I ask you a quick question?
Yeah.
And you don't have to do it, but what was the easiest way to manipulate the equations to get one of the variables gone?
So what I do is I just use the elimination method. I don't know what that method is called, but I just flip the coefficients of the first unknown I have, multiply each equation with them, and just cancel out V if I'm flipping it. So I mean, I'm not gonna do the whole thing, but I'm just gonna demonstrate it. So I'm just going to multiply this by 0.997 and multiply this by 0.075. So
Okay.
my coefficients of A will be the same. I'll subtract both the equations and I'll get VB and then substitute VB in VA.
That's what I thought. I thought it was a way to manipulate just one easily, but with these numbers being kind of nasty. I had
You can try solving it with matrix.
Got it. Okay. Yeah, multiplying each by the coefficient is probably easier for me.
Yeah, multiplying is easier, but you have decimals, then it becomes a little bit difficult. But if you're good with matrices, just go ahead and solve for matrices. Like VA, VB will be a 2 by 2 matrix, multiply it by x1, x2. Oh, wait, I still remember. How I'm amazed if I remember. Okay, 0.075, 0.60, 0.997, negative 0.79. You have x1 and x2 or VA, VB unknown equals 3.694 and 5.121. Something like this. I'm not sure.
Gotcha.
Yeah, you
Okay.
can get VA, VB from this. Yeah, solving the matrices.
Thank you.
But the easiest could be like if you want to just not solve matrix, just go with multiplying the coefficients.
Okay.
Yeah.
On the second equation where it says 3.9 cosine 30, I think that should be sine of 30 because the first equation was cosine 30.
Sorry.
Right there,
Oh.
the second one.
Yeah, sorry. That is why I guess someone was getting the wrong answer. I'm sorry.
That's okay. No,
This is sine. Yeah, thank you very much.
you're welcome.
This is sine. Yeah, so. Yeah, any other questions in this particular problem? Nice problem. When I saw this for the first time, even I got scared, but then when I solved it, I'm like, okay, this is algebra, nothing else. No. Okay. We'll go ahead and solve the next problem. This problem, I probably did this in today's session as well. I made this before today's session, so let me see if I can change it. It's better to change it. Because I'm gonna post the recording of my today's regular session as well for you guys. So I don't want to discuss same problems again and again. What do you guys have the most problem in, like chapter 13 or 14?
Well, I'm not on 14 yet.
14?
No, I haven't done 14 yet.
Oh, you haven't done 14 yet. Okay, that's okay. Okay, let's do this problem. From the previous chapter as well. This is a nice one. I mean, do you guys want me to do this rocket problem again? Are you good? I can do it. I'll just do it last if we have time. Oh, what happened? What did I do? Okay. Okay, perfect. Textbook problem again. So truck is hauling a 200 kg log out of a ditch using whatever it is, I don't know. They are attached to, okay, this sentence was not necessary, but okay. Knowing that it applies a constant force of 2000 newtons and the coefficient of kinetic friction between the ground and the log is 0.4, determine the time for the log to reach a speed of 0.5 meters per second. You gotta determine the time. What is the first thing that comes into your mind when you gotta determine the time? And this problem, you know that it's related to chapter 13. So what do you use? Impulse momentum, perfect. So you gotta use impulse momentum here. Okay. Impulse momentum, the general equation is mv1 plus f delta t equals mv2. This is the general form. The initial momentum plus the net force equals the final momentum. So that's impulse momentum. Now, first of all, we'll write the given. Tension is 2000 newtons. Tension is 2000 newtons. Then mu k is 0.4. And velocity of velocity is 0.5 meters per second. We have to find delta t. So we'll go ahead and draw the free body diagram, the kinetic diagram and the free body diagram. So it will look something like this for this law. So this is at 20 degrees with the horizontal. So mass times velocity, the first term, plus very bad drawing. Okay. So now we're going to draw forces. Forces, normal force. Normal force, weight, frictional force, and tension. This is going to equal, so this is force times delta t. This is going to equal mass times velocity of b. Okay. And what I did here was, in this case, I just tilted my axes. So This is going to be my y-axis. And this is going to be my x-axis. So I just tilted my axis. So I just have to take normal force component. So we have the given information with us. Again, this is bothering me. Very bad drawing. Okay. We have the impulse momentum diagram right now with us. Now we just got to write the equations using this. So first, tension, right? Tension, x-axis. So sum of forces will be 2000 times delta T. It's nothing but this value. Now, mass times VA. What is this going to be? Initial. The system going to be at rest at some point, right? So the initial momentum, the initial velocity is going to go to 0, right? Because you got to determine delta T. So delta T, if it doesn't say in the question, delta T would be T2 minus T1. At some point of time, the system would have been at rest. So T1 would have been 0. And if T1 is 0, so at T equals 0, the system is at rest. So VA will also be a 0. So in that case, my initial momentum go to 0. So I will just have F delta T equals mass times velocity, final velocity. So sum of forces times delta T would be 2000 tension going in the positive X direction, 2000 times delta T. Then when I will have frictional force will be mu K times N times delta T, right? So this is the frictional force. And then I will also have one component of mg. So this. So one component of mg, so this will be minus delta T. So this will be equal to 2000 minus normal kinetic friction is given 0.4 times the normal force. The normal force will be equal to the cosine component of mg, right?
Yes.
Awesome. So it would be mg cosine of 20 minus mg sine of 20. This times delta T. That would be equal to sum of forces times delta T. Now I will equate those sum of forces with mass times velocity too. So 2000 minus 0.4, mass is what, 200, 9.81, cosine 20 minus 200, 9.81 sine of 20 delta t will be equal to mass times velocity. So 200 times 0.5, which is the final velocity. So delta t from here would be equal to, if you do the calculation, you will get 0.169 seconds. Let me write this properly. 0.169 seconds. This was your final problem, final solution to this problem. It's easy if you visualize it, and if you draw the free body diagram, it becomes much easier to solve this kind of problem. So I have one more problem which I want to discuss. I have discussed it, I don't know, once or twice in my sessions, but that's a really nice problem. Most of the people get confused in that problem.
How did MVA equal to 0 again?
Oh yeah, I'll explain it. Yeah, just give me a second. So you have your equation, impulse moment equation, right? mv1 plus f delta t equals mv2, right? So here, the delta t. So in the question, it doesn't say anything about the initial time, right? So at some point of time, the truck would have been at rest. So if the truck is at rest, there is no movement of the log. And if there is no movement of the log, the velocity goes to 0, right? If the system is at rest, the velocity goes to 0. So if the velocity goes to 0, the initial momentum of the system goes to 0. Did that make any sense?
Yes, thank you.
Okay, yeah. It's not specifically mentioned in the question, but if it's not mentioned and you don't have any other thing in your question, you have that assumption that the system is starting from rest. Okay, so go ahead and so my favorite problem. I don't know, I have discussed it a couple of times, and a couple of attendees might know this problem as well, who have attended my sessions. So it's a nice problem. I don't know if you can see. Yeah. This is this is velocity v. Now you can see properly. Yeah. So in an ore mixing operation, a bucket full of ore is suspended from a traveling crane which moves along a stationary bridge. The crane is traveling at a speed of 12 feet per second when it's brought to a sudden stop. Sudden stop. It means velocity goes to 0. Your final energy or whatever you're solving for goes to 0 as well. And then you have to determine the maximum horizontal distance through which the bucket will swing. So I get a, it's just swinging, like, just imagine this bucket swinging like a pendulum. So first we will write given is V naught is 12 feet per second. And what else do we have? We have this distance. Let us name it as R. Again, it's not like it's radius or something. You can name it whatever you want. You can name it XYZ, doesn't matter. It's gonna stay 30 feet. So we gotta determine the maximum horizontal distance. Okay. So what we're gonna use is energy methods. So equations. So total energy, initial, total energy, final. Total energy initial, sum of kinetic energy plus potential energy. Total energy final, sum of kinetic energy final plus potential energy final. This is initial. It looks so easy, right? It's just kinetic energy initial, potential energy final, initial, you know, kinetic energy half mv squared, potential energy mgh. So the problem occurs at a different point in this question. So will I have any initial potential energy? The people who have done this, I know there are a couple of people who have been into my session and done this problem. Why do you, what is my potential energy initial? Zero. Awesome. It's going to be 0. And my kinetic energy final? Now you guys know that it's also going to be 0 because I'm specifically asking. Yeah, also 0, right? So it's gonna, the potential energy is gonna be 0 because it is going, the crane is traveling with 12 feet per second, and it is not, right now, it's not at a certain height, right? After the swing, it will have the change in height. So right now it's just standing still, but it's right after it starts swinging, it will have the traveling speed. And the kinetic energy final is gonna be 0 because we have this thing in the question, put to a sudden stop. Sudden stop means velocity final is 0, therefore kinetic energy final is 0. Yeah. Yeah, that's because it is a sudden stop. Correct. Yeah, correct. So this is gone. This is gone. Sweet. So we have half mv squared equals mgh. And note, in the question, you only have one thing given. Traveling speed of 12 feet per second. You don't have mass. And there is no way you can find the mass unless and until you physically go there and weigh it. In this question, to be honest. So you can think it that way as well. Okay, kinetic energy initial equals potential energy final. I can cross out my masses. So that makes sense, right? So this masses, they're going to get canceled. And anyway, they're going to get canceled because the mass is going to be the same. It's not going to change. We have velocity. Velocity is 12 feet per second. Gravity is 32.2. can find h, right? So this is gonna be 12 square over 2 times 32.2. So this is gonna be 2.23 feet. Now, this would be the vertical height traveled, right? But we gotta find the maximum horizontal distance. So how about we doing that now? Now this question needs proper visualization. So to solve for this question, we have this distance. Now imagine this bucket goes like this, okay? So it goes that way. So how can you draw the figure? So is this gonna be the whole thing here? Okay, this is 30 feet, right? That's R. This is the horizontal distance covered. This is also going to be 30 feet. And this will be Y, change in the height. So if this is Y and the whole thing is 30, this is going to be 30 minus Y, right? Just this. Can I find X? Yes, X will be what is Y? 2.23. So this would be equal to 30 square minus 27.77 square. So the horizontal distance X would be any questions, guys? Do you guys understand this or do you guys have any question?
Oh, that was easier than I thought it would be, actually. But I
Yeah.
like the way you explained the heights for the height and how to get the X.
Yeah. So it's like simply, it's like a pendulum. If it's going to have some change in height. So whatever your radius is or whatever the length of the string is going to remain the same. So this is also going to be 30, but the vertical height is going to be 30 minus the change in height. And then you can find the horizontal distance, the maximum horizontal distance possible.
Yes.
Yeah.
Wow, I like that. Thank you.
Anytime. Okay. Okay. This problem was nice. Enough of chapter 13, we'll do chapter 14. Oh, all of your guys' exams are next week? Or did I do the review session so early?
I think it's the week after spring break.
Oh, it's a week after spring break. Oh, I thought
Ours-
it's week.
Ours is next week, but
Oh, okay.
maybe
Okay.
some are different things.
Oh, yeah. Couple of weeks. Then it's good. Then this might help you. Anyway, even if it's after spring break, just watch the recording. I'll post it anyway. So. Oh, let's do this one. This one's interesting. Okay. We got some chapter 14 here. Okay. So three identical small spheres. Identical, the word identical. So masses are going to be the same. So we just get to play around with velocities. Each of weight 1 pound can slide freely on a horizontal frictionless surface. Okay, we don't need to worry about friction. Spheres A, B, and C are connected by a light rod and are at rest in the position shown where B is struck squarely by sphere A, which is moving to the right with a velocity of 9 feet per second in I direction, knowing that theta is 30 degrees and that the velocities of sphere A and B immediately after impact are VA equals 0 and VB is 5 in I direction and VBY in J. So we got to determine VBY and the velocity of C immediately after impact. Interesting question. So we have, let us write given first. Given things is V naught, this V naught, before impact, right? This is gonna be, oh, just crashed it. This is gonna be 9 feet per second. Theta is 30 degrees. We can already see that. So this is equal to 30 degrees. And VA, VB. Yeah. So what we'll do is we will again use conservation of momentum. So first we will look at the linear momentum. So now, if we are playing around with theta, we will have momentums in X direction and Y direction. So first, let us look at the momentum in X direction. Okay. So X direction, we have mv naught equals mva plus mvb plus mvc. similar thing which we did in this pool problem. Is the same thing. Masses, they are equal. So the fun I get of scratching it off, it feels so nice that I don't have to find it. Anyways, yeah, so V naught, we have been given 9 feet equals VA is 0 plus VB is 5 plus VC in X direction. So VC in X direction. Oh, not meters, feet. Velocity of C in X direction. Any problems?
No, not with that one.
Okay, perfect. And velocity of B here, 5, just taking the I component because it's in X direction. That is why I'm not including this VBY. Okay. Okay, so then we will go to Y direction. Okay, Y direction. We have similar kind of things. We will have V naught VAY plus VBY plus VCY, right? V naught, it's horizontal, lying on x-axis, goes to 0. VAY also gonna go to 0, right? It's lying on the x-axis as well. So we are only left with VBY is equal to negative VCY. We have two unknowns, VCY and VBY. So once we find VBY, we can find the VCY, and then the question will be complete. So this is the first equation. We need one more equation to solve this. So now, what should we do? Does anyone have any idea? Think about what should we do. I've used conservation of momentum in X and Y direction. Now I still want one more equation so that I can solve for VCY and ultimately for VBY. What else or what other formulas or relations I can use in this problem?
Could we use the one where it's like E equals VB2 minus VA2 over VA1 minus VB1?
Yeah, that's a nice thought. But do you have E?
No, that's
Right.
the only problem.
Yeah, that's the only problem. If you had coefficient of restitution, probably you would think of using that and then equating both of them and then get the answers. But we don't have the coefficient of restitution. So if we involve that equation, we will get one more unknown. So by adding that equation, we'll increase the number of unknowns. So we want something. Can we think about angular momentum as well here? Because I can find the radius with respect to origin of all the 3 balls. And the angular momentum is nothing but the radius cross product it with the mass times velocity, the linear momentum. So is H, it's denoted by H. I don't know why, like angular momentum and H doesn't go well, but okay. Is radius cross product with mass times velocity. I know some of you have not yet, the professor has not discussed chapter 14, so this will look new to you, but this is nothing. This is just it's just radius multiplied by the linear momentum which you used to find. So we can use angular momentum here, and we can say that, okay, my sphere B is lying on the origin, so radius of B would be 0, right? And radius of A, what will be the radius of A? Radius of A would be 0. Great. Radius of A would also be equal to 0, because I don't have any perpendicular distance which connects the origin to the sphere. So I don't have radius of B, I don't have radius of A. That is amazing, because angular momentum in that case, if I cross product it, it would come out to be 0. So the only thing I need to find is angular momentum with respect to C, so that I can get VCY. And then ultimately I'll get VBY. So radius of C this C is gonna have 2 components, right? Well, let me draw it with a different pen. This will be 1.5 cosine 30 and 1.5 sine 30. So radius of C would be 1.5 cosine 30 in I direction plus 1.5 sine 30 in J direction. Everyone agrees with that? Does anyone have any problem? It's here. So it's 1.5 feet is the distance and angle is 30 degrees. So I can find the radius in terms of I and J. Now 1.5 cosine 30. So if I cross RC cross M dot VC, so this would be equal to, I'll just change this, cosine 30 is square root 3 over 2. So this would be for J. Cross product it with M VCI plus M VCJ equals 0. So now form the matrix, not matrix, sorry, determinant I, J. We don't have K, so just 2. So 3 root 3 over 4, 3 over 4, VC X and VCY. This is in Y direction. Equals 0. So this case, right? And now I also have one more triangle that is formed here, and I can also form the same triangle as I formed for my radius. I can say that, okay, this is pier C, 30 degrees, VCX is gonna be here, and VCY is gonna be here. So I can say using trig functions, tan 30 is VCY over VCX, right? So VCX is gonna be tan 30 VCY, right? VCY we have been given. No, we have not been given VCY. Okay. Oh, we can use this relation. So VCX is going to be oh, did I do something wrong?
Didn't we find VCX like further up in the problem?
Did we? Oh, we did. Oh my God, I'm so dumb. Thank you very much. I was just thinking, what am I doing here? So yeah, we found VCX. It's true. So VCX, just replace 4 here. So VCY is going to be 4 over root 3. And 4 over root 3 is 2.31 feet per second. Thank you very much. And yeah, once we have VCY, VBY is negative of VCY is going to be negative of 2.31 feet per second. So this is going to be the final solution for the question. Yeah. And if they tell you to find the magnitude of velocity of C, you have VCX, VCY, square root, take the square of VCX, VCY, add them, and you will get the magnitude of velocity of C. But they don't ask the magnitude. So we're just gonna leave it as VCX and VCY. And obviously we found VBY as well. Any questions? Yeah, this was the way I was gonna solve it. This was the second way I was gonna solve it. You can also take, this is much easier. Tan 30 is VCY over VCX. So VCX you already have, multiply it by tan 30, which is 1 over root 3, and you'll get VCY. So that approach is much faster and easier than the angular momentum. I just did angular momentum to just introduce the concept of angular momentum, because you'll have questions in chapter 14 regarding angular momentum as well. So yeah. Any questions?
No, not on that one.
No? Okay, perfect. Sweet. Okay, let me see if I have more. Oh, that's a nice question. Okay. So also textbook question, 14 chapter. Four small discs A, B, C, and D can slide freely on a frictionless horizontal surface. Disc B, C, and D are connected by light rods and are at rest in positions shown when disc B is stuck squarely by disc A, which is moving to the right with velocity of 38.5 feet per second in I direction. The weights of the disc are WA equals WB, WC 15 pounds, and WD is 30 pounds. Knowing that the velocities of disk immediately after the impact is VA equals VB equals 8.25 feet per second in I direction, and VC, of course, we need to find that. So determine the speeds of VC and VD and the fraction of initial kinetic energy of the system, which is dissipated during the collision. Too much in this problem. Anyways, we're gonna start solving it. We just have like 30 minutes. So let me quickly start solving it. Okay, so first, are there any external forces in the system? Any external forces? No, right? So if there are no external forces, our favorite statement, momentum, is conserved. Right? And let me actually depict this with a nice picture so that you guys more understand it. I'm gonna try drawing this. V naught. This is going to equal to, okay, C is going to move with mass of C, velocity of C. Agreed? When MA V naught hits this system. In B, it's going to, two masses are going to get combined. And this is going to move with MA plus MB, velocity of B. And third one, again, is going to move independently with mass D and velocity of D. So what we're gonna do is, we're gonna do some trick here. We're gonna take moments about t. So a little bit of statics involved in dynamics, which is a dangerous combination, but this is how the question is solved. So gonna take taking counterclockwise as positive. Oh, clockwise, sorry, clockwise. Okay. So taking moments about d, I'll get is write this velocity of a p equals 8.25 and v naught is 38.5. So if I take moments about d, I get the distance is 3 feet. If I take mass of A, the distance is 3 feet. So this is going to be mass of A times V naught, right? Equals the distance of C is 6 feet in total till point D. So this is going to be 6 mass of C, velocity of C, plus again this distance is 3 feet, and I have 3 mass of A plus mass of B times velocity of B. It's not that difficult if you write equations correctly. So VC, in the end, what do I need to find? VCI, right? So VC, if I rearrange the equation, I'm going to get 3MA V naught minus 3MA plus MB VB over 6 mass of C. So do I have every information with me? All right. Three times mass of A is 15. 32.2 times velocity of C. Oh, sorry, not times velocity. Well, V naught. V naught is 38.5 minus 3. 15 plus some mass of A plus mass of B. Weight of A, weight of B are equal, 15 pounds each. So it's going to be 30 pounds over 32.2 times velocity of B. Velocity of B is also 8.25 over 6. Mass of C is 15 pounds again. So I didn't even need to divide it by 32.2, to be honest, because if we take common, it's going to cancel each other. So we have 3, 15, 38.5 minus 3, 38.25 over 6, 15. I can also take the 3 common. So this multiplied by 2, make it much more easier. 15 I can take common. Okay, I don't want to take anything now. Okay, can anyone do this calculation and let me know what they get for VC? $11 feet. Amazing, amazing. 10.8. Richard, I mean, just check your calculations again. It should round up to 11 feet per second. And I don't know if it's 10.8 or 11, but 11 feet per second sounds good. BC is going to be 11 feet per second. Yeah, it's 11 feet per second. Now, I have my VC. What I want to find is VD. What I'll do is, if I wanted to find VC, I took moments at point D so that VD gets cancelled. And if I want VC, I'll take moments at point C. So point C. Again, this time you can change the direction. Counterclockwise is positive, right? Because what happens is A goes this side, so C is gonna go the other way. C is gonna go counterclockwise and D is gonna go clockwise. So anyway, if I assume that my counterclockwise is positive, then it makes much more sense. So same, I have to do the same thing. So in this case, I'll have 3 mass times A velocity, because the distance is going to be the same. The distance is symmetric. So it's like 3 feet here as well. So this A is 3 feet away from C. So it's going to be 3 ma v naught. D is going to be 6 feet away. So it's going to be 6 mass of D, velocity of D, plus again mass of A plus mass of B is going to again be 3 feet away. And this is going to be multiplied by velocity of D. Right? Rearranging this equation, VD equals 3 mass of A y naught minus 3 mass of A plus mass of B VB over 6 mass of D. So let me take this common. So it's going to be 2. So mass of A is, again, I don't need to divide it by 32.22 because eventually it will get cancelled, because in numerator and denominator we have masses. So I'll just take the values. So mass of A is 15. V naught is going to be, what is V naught? 38.5. Minus mass of B plus mass of A is 30. VB is 8.25, I remember. Yeah, 8.25. And 2 times mass of D is going to be different. It's going to be 30. So, yeah. So VD in this case would be 5.50 feet per second. Any questions still here, guys? Is this complicated? Or do you feel okay about it? Do you understand everything? Okay, perfect. So let's go with the second part. For the second part of question, we need to determine the fraction of initial kinetic energy of the system which is dissipated during the collision. So initial kinetic energy, T initial kinetic energy is gonna be half mass of a V naught square, right? So this is gonna be half mass of A is 15 over 32.2. V naught square is 38.5 square. This is going to be 345.24 feet time pounds. Final kinetic energy let me write this kinetic energy or you guys will get confused. That you will get confused with this total energy. It's not the total energy, it's just it's in kinetic energy. So it's kinetic energy initial and kinetic energy final. This is going to be half times mass of A plus mass of B, VB square, plus half mass of C, VC square, plus half mass of D, VT square. Simple. You have every value with you. So half mass of A plus mass of B is 30 over 32.2. Velocity of B is 8.25 square plus half mass of C is 15 over 32.2 and velocity of C is what do you get for velocity? 11 feet. So this is going to be 11 square plus half mass of D is 30, so 30 over 32.2. Velocity of D is 5.50 square. So if you add everything, you will get KE final equals 73.98 feet per pound. Okay. We gotta find the energy dissipated. So that's equal to energy lost from the system. Energy lost, fraction of energy lost, it's gonna be T, not again T, no T, okay. Kinetic energy initial minus kinetic energy final upon kinetic energy initial, right? So kinetic energy initial was 345.24 minus final was 73.98 feet per pound over initial is 345.24 feet per pound. So I get fraction and that fraction is equal to 0.786. Energy lost. Let me write it again. Yeah. Okay. Was this a difficult question at all? Like, if you understand what's going on in the question, it's not at all difficult. You're just gonna strike like, I don't think so on the first try you will think about finding the moments to find the unknown velocities, right? You'll just
Yes.
yeah, you just think about conservation of momentum. But what happens in conservation of momentum is, okay, you can take conservation of momentum, but then you don't know VC and VD. If VD was known, or if VC was one or the other one, if it was known, then you can try and use conservation of momentum. But if you know that the momentum is conserved, the moments, they are gonna be equal to 0. And if you want to find one moment, if you want to find one velocity, take the moment at the other point. So nice problem. I'm doing it for the first time. I've never done it before, like in my previous sessions. I kept this for some of the problems for my review session. So yeah, it's a nice problem. Okay. Yeah, so we solved, I don't know, 1, 2, 3, 4, 5, 6 problems. Oh, 6 dynamics problems, not bad. I was going to solve the cable one, but I guess most of you, like, I have solved this twice in my sessions now, the cable one and the rocket one. I have solved this one as well, like twice or thrice in my sessions. So I don't think so you will have problems in this particular questions. But if you have, I'm going to post my recording, which I did from 11 to 1, the recording. So both the problems are in that recording as well. Just watch that. Watch this recording again if you want. I'll post the solutions by end of today or tomorrow. Most probably it will be tomorrow, because I kind of like be late today. So yeah, any last minute questions?
Can you just scroll back to the bottom of the last problem we did?
Yeah.
Thank you. Yeah, thank you.
Yeah. And if you guys want to just go ahead and rate, I'll share the thing. I'm sorry I'm asking you for the survey to fill up again and again, but yeah, if you guys can go ahead and fill up the survey, like the Qualtrics form for us. Wait, let me just share the QR code, share my screen again. Can you guys see the screen?
Yes.
Perfect. So if you scan this QR code, it will take you to rate your tutor evaluation. If you can just fill up that form, just take you 5 minutes. It will be great for me as well. And any other last minute questions? I'm going to post the recording. I'm going to post my review worksheet on my WordPress site. And my WordPress site, if you just type, let me just type here. WordPress UCFPA tutoring. If you go to this WordPress site, go to engineering, go to my page, and everything will be posted here by the end of tomorrow. So yes.
Thank you.
Yeah, anytime. Any more questions, last minute questions? If you have, don't feel
No, I don't have any more. Thank you, Kate. Thank you for your time.
We'll do good. Don't worry about it.
Thank you. Have a good day.
Yeah, you too. Bye bye.